Hey there! Welcome to the Spirit Airlines training video covering an engine failure after V1. The purpose of this video is to demonstrate an engine failure after V1 and highlight the critical steps that should be taken in accordance with the FCTM, the ECAM, and other Spirit Airlines manuals. The overall objective is to accomplish these procedures while complying with standard policies, limitations, and callouts. In this video, we will demonstrate an engine failure with damage. We will then follow it up with a discussion on considerations and differences for an engine failure without damage leading to an engine relight in flight. We recommend that during the upcoming engine failure demonstrations, you follow along on your AFB step by step to reinforce your knowledge of an engine failure after V1. To do this, open the OLB, select FCTM, Procedures, Abnormal and Emergency Procedures, Engine failure after V1. You can also reference the Spirit Airlines training video on management of abnormals for more detailed information on OEB, ECAM, and EQRH handling. As always, we recommend selecting Layer 3. Our manuals are always governing. If any information in this video differs from our manuals or future revisions, please always comply with our manuals and federal aviation regulations. Let's get started and jump right into engine failure after V1.
This engine failure after V1 tutorial will be expansive and include pauses in between important sections to highlight considerations for that section. Before we begin with our scenario, let's set the scene. Today we are departing from Seattle-Tacoma International Airport, runway 16 center. Current visibility on departure is 1800 RVR, as opposed to our traditional validation scenario of 500 RVR. This means that Neil and John briefed the single engine procedure and plan for a return back to Seattle in case of an emergency. Remember that if weather conditions at the airport of departure are below landing minimums for that airport, Cat 1 being the lowest, you'd build the secondary flight plan to your departure alternate as required by SOP. Now Neil will show us how to build all this on the secondary flight plan. We are showing this as a means of providing the appropriate way to build this particular engine failure procedure since it's a common mistake during training. First, Neil will add the Seattle VOR. This acts as an anchor point for the 161 radial our procedure requires us to fly. And then in order to build the 161 radial, he'll build a place-bearing distance fix long enough to give time to climb and troubleshoot the engine failure. Next, you add the departure runway, but delete the first fix, the altitude associated with the departure runway, to make sure it sequences correctly. And then we pretend that that didn't happen. We'll push the clear button, and then delete the discontinuity. Alright, there we go. You put the arrival runway and you're good to go. In this case, Neil opts to use ILS 16 center since the weather is better than Cat 1 weather, in order for an immediate return to Seattle. Alright, that's pretty much it. Without further ado, let's go to Neil and John for our engine failure after V1.
Spirit Wings 101 Seattle Tower, winds are 250 at 10 knots. RNAV Otley, runway 16 center, clear for takeoff.
RNAV to Otley, 16 center, cleared for takeoff. Spirit Wings 101.
Takeoff. Man flex, SRS runway, auto thrust blue.
As with any takeoff, focus on maintaining runway centerline and do not anticipate the engine failure.
Thrust set. 100 knots.
Checks.
Focusing on keeping runway centerline will allow you to naturally react in the event of an engine failure. Once you've established directional control, maintain that rudder input.
V1, rotate. Engine failure.
At VR, pilot flying rotates by using a continuous pitch rate of approximately 3 degrees per second towards an initial pitch attitude of 12.5 degrees. This will ensure the aircraft becomes airborne. Next, the pilot follows SRS to maintain the appropriate target speed. Notice in addition that pilot monitoring did not identify the specific engine that failed. This is done later on in the procedure. just announce engine failure.
Positive rate.
Gear up.
Gear up.
The rotation is probably the most crucial aircraft handling component of this maneuver. Here are a few tips and information from the FCTM that will help you succeed. Remember, the aircraft takes 5 seconds to transition from ground to flight mode of normal off or pitch, and half a second for the lateral control. During this transition, any rudder movements will additionally be translated to roll due to dihedral effect. This would lead to unwanted bank. Even in flight mode of lateral control, abrupt rudder movements will result in bank. Try to minimize rudder movements, or if slight rudder correction is needed, be prepared to apply a small bank correction in conjunction. In addition, be cautious of pitch inputs that may lead to over-rotation or neutralizing the side stick before being in pitch flight mode. This could lead to your nose coming back down since the aircraft has not finished trimming. Focus on maintaining SRS vertically, and with wings level, smoothly adjust the rudder with the rudder pedals to center the beta target. Notice the FCTM actually says lateral normal law, add some rudder surface deflection, therefore there is no rush on adding the additional rudder needed to center the beta target. This doesn't mean don't do it, it just means that you don't have to rush and should be smooth with the addition of rudder to center the beta target. Once the beta target is centered, use rudder trim until the pressure is relieved on your feet. Do not use a specific trim number. This varies depending on your aircraft's weight, speed, and environmental conditions. Trim the rudder enough to feel no further foot pressure is needed to maintain the rudder pedal position. If your rudder is fully deflected and the beta target is still not centered, increase airspeed to improve rudder effectivity.
Select heading 164. Activate secondary. Manage nav.
In older FMGC software, selecting heading will enable the Activate Secondary prompt.
Nav.
Shuttle Tower, Spirit Wings 101, Mayday, Mayday, Mayday. We've lost an engine. We're going to track the 161 radial outbound. We'll give you a call back here in a few minutes.
Spirit Wings 101, roger. Copy your Mayday. Contact departure on 120.4 when able, and we'll relay the information.
Spirit Wings 101, roger. Engine 1 fail.
Autopilot on. AP1. ECAM actions.
ECAM actions. Engine 1 fail. Engine mode selector ignition. Thrust lever number 1, idle.
Confirm thrust lever 1.
Confirm thrust lever 1.
Idle.
If no relight, I don't see a relight. Engine 1 master off. Confirm engine 1 master.
Confirmed.
Off. If damage.
Now the crew considers whether the engine failure was a flameout with no damage or a failure with damage. Note the symptoms listed, which would help identify an engine failure with damage. These can be found as a Layer 2 note displayed within the engine failure procedure in the FCOM.
What do you think, Neil? I think there's damage. You agree?
I agree.
Okay. If damage, engine 1 fire, push button, push. Fire, engine 1 fire, push button, confirm.
Confirmed.
Pushed. Agent after 7 seconds, discharge. Agent 1 discharge. If no damage, that doesn't apply to us. Shutdown. If no fuel leak.
Vertical speed 0.
There are two occurrences happening at the same time here worth mentioning for both pilot flying and pilot monitoring. The aircraft has reached the engine out acceleration altitude. Note that Neil pushed the VS knob to level off and allow the aircraft to accelerate. If flying with the autopilot off, which is not the case in our video, the acceleration makes the rudder more effective, meaning pilot flying would have to retrim the aircraft. Maintain the thrust levers at the current position. A common error is to command toga at this point, which will result in an unduly activation of the go-around phase. As for John, he reaches the fuel leak conditional statement. He will diagnose if there's a fuel leak to determine whether or not the subsequent ECAM actions apply. Here are the different means our QRH provides to detect a fuel leak. An appropriate means to go through the identification at this time is to add fuel on board and fuel used. The sum of these two numbers should be close to the fuel on board at engine start.
So we have 1,000 plus 90. Yeah, we left with about 2,000. That looks about right. I don't think there's the leak. You agree, Leo?
I agree.
TCAS mode selector TA. Void icing conditions. Clear engine 1.
Clear engine 1.
We have land ASAP in amber. Air bleed. We've lost engine bleed from the first. We've lost pack 1. Pack 2's powered. Clear bleed.
Clear bleed.
Electric. Looks like we've lost Gen 1. Gen 2's powering all the buses. Would you like me to start the APU?
Start the APU.
Clear electric.
Clear electric. Stop ECAM.
Remember to stop ECAM prior to any configuration changes.
Flap 0.
Speed checked. Flap 0.
Continue ECAM.
If performing a flaps 2 or 3 takeoff, pilot flying may order pilot monitoring to continue ECAM while the aircraft accelerates, workload permitting. As per the FCTM reference shown, when the speed trend arrow reaches the green dot speed, pull the altitude knob to engage open climb. This will automatically change the managed speed target to green dot, so there's no need to select green dot prior to pulling the altitude knob. You'll receive a lever MCT message on your FMA. If you're at Toga, bring the thrust lever back to MCT, or if you're already at the flex MCT detent, move the thrust lever to climb, then back to MCT.
Hydraulic page. We've lost the engine-driven pump on number 1 engine. However,
Open
all
climb.
systems are powered. Clear hydraulic.
Clear hydraulic.
Status.
Stop ECAM. Thrust MCT, auto thrust. Okay, the after takeoff flow has been accomplished.
I agree.
After takeoff checklist.
Takeoff checklist. Takeoff checklist is complete. Over, we have the APU running.
Thank you. There's no system resets,
No.
and an engine relight is not applicable.
Not here.
Continue ECAM.
Avoid icing conditions. If severe ice accretion, that doesn't apply to us. You agree?
I agree.
All right, so we'll skip that. Landing distance procedure apply. If no engine 1 damage, consider relight. That's not going to apply to us. Cat 3 single only. Inoperative systems are wing anti-ice, Cat 3 dual, engine 1 bleed, reverser 1, engine 1 start, pack 1, gen 1, and green engine 1 pump. Clear status?
Clear status.
ECAM actions complete.
Thanks, John. How about you ask for a turn back towards Seattle and a lower altitude?
Spirit Wings 101 emergency aircraft requesting level off at 4,000 feet and a right turn back towards the Seattle airport.
Spirit Wings 101, Seattle departure. Roger, approved as requested. Climb maintain 4,000, turn right heading 330. You can expect vectors for the ILS runway 16 center approach. Current 16 center RVR 1800.
Okay, we copied radar vectors for the ILS 16 center. We'll call you back and let you know. Climbing to 4,000 feet, right turn heading of 330. Spirit Wings 101.
Heading.
Spirit Wings 101, thank you. And when able, say souls on board and fuel remaining, please.
Spirit Wings 101. Roger, we'll give you that information in just a minute.
4,000 blue.
4,000 blue, 1,000 to go.
Checks. Would you mind checking the EQRH for additional procedures, please, John?
Remember that the EQRH procedure doesn't necessarily have to be the title of the ECAM for it to apply.
Okay, it looks like we do have a 1 engine inoperative straight in. That just is whether it's going to be no level off or if we're expecting to level off during the final approach.
They were advertising the ILS, so I assume there was going to be no level off.
I like it. So in that case, it says just delay full config until established on final descent.
Excellent, thank you. So the EQRH is complete. How about we hold off on the FCOM so we don't prolong the flight for right now? Let's get the ATIS. Let's recall the status to assess the situation. And let's consider fuel penalty factors, our landing distance back in Seattle, maintenance, operational, and commercial aspects, and then we'll make a decision on where we should go.
I like it.
Once we make that decision, we will then tell ATC, dispatch, the lead flight attendant, and the passengers.
Sounds good to me.
Despite receiving a landing distance procedure apply message on the status page that is only related to ice accretion, this particular failure can be found and should be added to FlySmart when running your landing distance assessment, even if there is no ice accretion. You'll notice that landing performance is affected due to the inoperative reverser on the failed engine. For brevity purposes, we'll go ahead and fast forward the first part of this demonstration since it's identical to having an engine failure with damage.
V1, rotate.
Notice with this engine failure, EPR decreases without any other symptoms of engine damage, like we discussed previously.
Positive rate.
Bring us forward to the beginning of ECAM actions. Pay particular attention at the point in time the crew decides to complete the engine relight, once there's been a determination that the engine flameout did not involve any damage.
Engine 1 fail.
Autopilot on. AP1. ECAM actions.
Engine 1 fail. Engine mode selector ignition. Thrust lever 1 idle.
Confirm thrust lever 1.
Confirm thrust lever 1. If no relight, I don't see any relight. You agree?
I agree.
Engine master 1 off. Confirm engine master 1.
Confirmed.
Off. If damage, I don't see any damage. Do you agree?
I agree.
All right. If no damage, engine 1 relight consider. So we'll consider that in a bit. Shut down. If no fuel leak. Imbalance monitor. So we got 700 plus that. So it's about what we left with from the ramp. So I don't expect a fuel leak. TCAS mode selector TA.
Vertical speed 0.
Clear engine 1.
Clear engine 1.
Notice the engine relight was not accomplished when the ECAM stated to consider the relight. The crew first analyzes the SD pages, then, when reaching the status page, they will consider performing the engine relight as stated within the FCTM.
Status.
Stop ECAM. After takeoff flow has been accomplished.
All done.
After takeoff checklist.
After takeoff checklist. So it's all done, however we've got the APU running.
Copy, thanks.
After takeoff checklist is complete.
There's no system reset here.
Nope.
Let's attempt an engine relight.
All right.
Reference the EQRH for the engine relight procedure.
All right. All right. Engine relight in flight. Max altitude see above. Let's see. 210 knots going through 2,000 feet. Looks like we're within the relight envelope.
Excellent.
Engine master affected, engine off. That's off. Thrust lever affected, engine idle. That's at idle. Engine mode selector to ignition. That's ignition. Cross bleed open. Air cross bleed open. Wing any ice for starter assisted off. Wing any ice is not on. Engine master affected, engine on. Confirm engine 1.
Confirm engine 1.
On. We should get a light off within 30 seconds after fuel flow.
Remember to keep your hand on the engine master switch in case of a start fault, which would have to be manually aborted since we're airborne. We'll skip to the point where the engine relight is complete.
So it looks like we got a light off.
Notice the items on the status page progressively disappearing as the engine comes online.
You got a veil.
Once you see the avail message within the engine parameters, the engine is considered successfully relit. Read and do the remainder of the QRH procedure, otherwise fulfill the if no relight actions within the same procedure. That's it for me, everybody. Thank you all for your continued attention and support to our training videos. Here's Sebastian, signing off. Back to you, Neil.
This concludes our video covering an engine failure after V1. Please make sure you're familiar with all sections of the ECAM, FCTM, and the FOM that dive deeper into other aspects of this topic. We hope you have enjoyed this video. The more proficient you are with this topic, the better situational awareness you'll have if you encounter an engine failure after V1. As a reminder, our manuals and regulations are always governing, and compliance with them supersedes any information found in these videos. Fly safe.